Hi, I'm Sam.
I'm JD.
I'm Luke.
And I'm Leslie, and we're the Bubble Blowing Babies. For our FEDD project, our goal was to create a new bubble blowing machine. So the first step of the design cycle we went through is ask. We had to identify the answer to a couple of questions, such as, what should we use to power the machine? What ingredients should we use for the bubble solution? How do we achieve electrical safety? And how do we improve upon previous patents of bubble machines? Through our preliminary research, we were able to answer these questions. We learned more about the basics of electrical circuits, switches, motors, and parts of simple machines such as gears.
After answering these questions, we moved on to the second step of the cycle, imagine. Through looking at designs of previous patents such as the bubble blowing device by Emmett Holman, in addition to finding other do-it-yourself projects, we brainstormed a couple of potential designs we could use for our own bubble blowing machine. Our first sketch was a very rough design of what would become our stencil for our bubble wands. Our second idea was a cylindrical object with pipeline configured throughout to act as our bubble wands. But after brainstorming some more, we decided on this design instead. This design involved a DC motor rotating on one axle that has a large gear and wheel with holes attached to it. Above it is a parallel axle with a smaller gear and fan blades attached to it. The fan blades would be aligned with holes of the wheel, and the bottom portion of the wheel would be submerged in a trough of bubble solution. At this point, we are more in the planning phase of the design cycle. For our design, we plan to complete the majority of this project in the wood shop of the craft center on campus. The materials we would use include wood, 3D printed gears, and a wheel. And for the solution, we initially planned to just use Dawn dish soap and water, but we later incorporated corn syrup too. Acknowledging our $40 budget limit, we plan to gather the materials in advance and then proceed with our design timeline of completing our prototype within a month so we could go through the cycle at least once more.
Once we established our plan for building the bubble machine, over the next 2 months we met at the craft center to create our prototype. We first built our 2 support beams which would hold the bearings and the axles. Then we found a block of wood which we drilled a hole that the motor could sit in to spin the main axle. When testing our motor, we initially attached our pencil axle using only the rubber eraser on the end, but it was unstable, so we instead drilled a hole into the pencil to make it a little more secure. Later on, we secured it even more by attaching the motor to a block which fit the pencil inside of it. Once we finished the base of our design, we were able to design and 3D print 2 gears with a 1:5 ratio in the wheel that the bubbles would be blown out of. One of the first challenges we encountered was getting our gears to spin smoothly because sometimes they would get stuck and the motor was not strong enough to continue revolving. However, with problem solving, we determined we could cut part of one of our support beams to reduce how tightly the gears were touching each other. We then moved on to creating our own fan, trough, and bubble solution to finish our prototype. When we tested it for the first time with the fan attached to the machine, we realized that the current design was not capable of blowing bubbles.
After completing the creation phase, we then looked towards improving upon our prototype. From analyzing the results of our initial testing, we identified a couple of design features that we could change to create a better product. We decided to alter the design of our fan to help aid in the strength of air being moved. With our new fan, we designed it so the air would be more concentrated in one spot. Furthermore, we incorporated a second motor to run this fan rather than relying mainly on the speed of rotation caused by the turning of gears and the axles. Secondly, we relocated the motor to be attached to the smaller gear. Since the wheel was attached to a large gear, it slowed down the rotation, allowing for the fan to more easily blow bubbles. We initially found that attaching the motor directly with the axle connected to the wheel made it spin too fast, which would make it difficult to form bubbles. This also made it easier for us to resolve the issue of the gears being too crowded, which had made it prone to jamming. Lastly, we tweaked our bubble solution to include corn syrup and more soap, so the bubbles being formed would be stronger compared to the original solution, which only had soap and water. After we implemented these improvements, we secured everything down, organized the wiring, and decorated it with a beach theme.
With our project successfully completing testing and meeting the results we were looking for, we were ready for FEDD. That morning, our product was working relatively well. One of our 2 main concerns was we were using new batteries, which made the wheels spin faster than usual, causing the solution to splash out. Also, the axle had become loose, which altered the alignment of our gears. We temporarily fixed this with hot glue, but then at the competition table, our machine ended up jamming after running for 30 seconds, which had not happened during our final testing before FEDD. With that being said, we did not end up placing at competition, but this experience reminded us of the fact that failure is always part of the entire process. What's important is what we take away from these failures. If we had to do this over, something we could have changed is to try to make a new prototype each time rather than trying to simply build off of our previous design. Furthermore, parts of our design used hot glue, which may not have been the best way to secure the various components of our bubble blowing machine. We could have also found a way to lessen the amount of friction the motor had to overcome.
Some general advice we have for future E101 students completing this project include making sure to know your resources. There's locations like the Makerspace and Craft Center Workshop, which you can utilize to help you complete your projects. Make sure to go to the orientations earlier because later in the semester they are less likely to be offered. There's also the resource room located in Daniels Hall, which has many free resources. As a team, we wish we knew about this earlier because that would have reduced the amount of money we had spent for this project. Lastly, don't give up if something doesn't go your way and stay on top of deadlines so you can save yourself some stress of not having to cram the few days leading up to FEDD. The design process has its ups and downs, but it allows you to get a glimpse into what it is like to be an engineer.